Okay, so one of the last new topics we're going to talk about before we finish up Unit 1 is the average rate of change over an interval. So on the picture you see here, this blue function, it's kind of this parabola, upside down shape looking thing, is it also has a red dotted line on it. Now this red dotted line would be a representation of what the average interval of change would be if I went from the interval -4 to -1. Because right here is -4, and you can see that's where the red dotted line starts, and right there is -1. So it's kind of like if the question said, hey, what is the average rate of change over that interval? You would essentially take your pencil, pen, colored pencil, whatever, and you would draw a line that goes from point A to point B over that interval, okay? And essentially all we're going to do is we're going to find the slope of that line. And if we can find the slope of that line, that'll give us the average rate of change from -4 to -1. So, that said, what is the equation for the slope of a line? Well, if you recall way back to geometry, okay, the slope of a line is always the change in the y value divided by the change in the x value. And that little triangle just is a symbol for change. Now, the other way that you saw it, which is probably the way that you're more familiar with it, is y2 minus y1 divided by x2 minus x1. Okay? Your change in the x is going to be going from here to here. That's your change in x. And your change in the y value, that's going to be going from here down to here. That'll be your change in y. So you can do this one of two ways. You can just count it, or you can identify these points and use the actual points. This point up here is to the left 4, then up 1, 2, 3, 4, 5, 6. So this is the point -4, 6. And then the other point down here would be the point -1, 2. So we're going to call one of these x1, y1, the other one x2, y2, and we're going to throw them into this equation. That's going to give us the slope of the line. That's going to give us the average rate of change. Okay? So, it's really up to you. Let's call this one x1, y1, and let's call this one x2, y2. And let's go ahead and let's throw these into the equation. Now, one thing that I always say about the slope of a line equation, I say put your fraction bar and put in the minuses, because then that helps you, it helps prevent you from making mistakes when you plug in the 4 numbers. If one of them's negative and there's already a minus there, some people make a mistake there. So my y2 is going to be 2, and my y1 is going to be 6. My x2 is going to be -1, and my x1 is going to be -4. And there's that minus and negative that sometimes people mess up on. So now I'm just going to reduce this. Well, 2 minus 6 in the numerator is a -4. -1 minus -4. Anytime you have a minus and negative, that becomes a plus. So -1 plus 4 is 3. Okay? So the slope of this line is -4/3. That is our average rate of change from one point to the next. So over that interval, on average, I'm going down 4 to the right 3, down 4 to the right 3. Let's look at another one of these. So here's a little graph that's the average baseball salary from 1989 to 1998. And on the left is the salary in millions of dollars. Now, some of you may know what baseball salaries are like nowadays, but if you look back at this in 1990, the average salary was about $500,000, $500,000. So not quite as much. That's probably less than the league minimum now. So the important part here is that the interval that we're looking at is from 1990 to 1994. That's from here to here. So the corresponding points on my graph are there and there. That's the interval I'm looking at. This is my change in my x value, and the change in my y value is going to be from here to here. That's my change in y. All right. As far as our actual points go, the actual points are 1990, comma, and then I go up to, boy, I don't know, I guess we'll call that, for the sake of argument, let's just call that 0.6. And then up here I have the point 1994 and 1.2. So I'm going to call this one x1, y1, call this one x2, y2. I'm going to go over here. My formula is y2 minus y1 over x2 minus x1. So I'm going to start just by putting the fraction bar in the negatives, minuses. So my y2 is 1.2, my y1 is 0.6, my x2 is 1994, my x1 is 1990. Now sometimes people are like, well wait, you're putting a year in for your x value, that doesn't make sense. Well, it does make sense in that really all I want to know is that it was an interval of 4 years, right, from 90 to 94. 1994 minus 1990 is an interval of 4 years. Okay, and then up in the top, 1.2 minus 0.6 is 0.6. All right. Now I'm going to grab my calculator here and I'm going to simplify this down because we're talking about a rate of change here. So 1 second. Whoops, sorry about that. I wanted to get my calculator and forgot to pause it. Whoops, sorry about the dead time there for a minute or so. So anyway, so now that I have my calculator, I did 0.6 divided by 4, and that's going to give you 0.15. Now let's go ahead and let's change that to a percent. If we're looking for rate of change, percent's probably better. Anytime I want to change the decimal to a percent, I can take that 0.15, multiply it by 100, and that's going to give me the percentage, which would just be 15. It's the same thing as moving the decimal 2 to the right. So this is a 15% increase over that interval. And now that I think about it, we didn't do that on the first one, so let's take a quick trip back. Let's do 4 divided by 3. That's basically negative 1.33 repeating. If I multiply that by 100, that's going to give me a percent. Essentially I'm decreasing at 133% over that time. Okay? That's the rate of change. The rate of change.